హాయ్ వ్యూయర్స్, వెల్కమ్ టు అవర్ ఛానల్ టీచర్ డైరెక్టర్. ఈ వీడియోలో మనం 10th క్లాస్లో 11th చాప్టర్ ఏరియాస్ రిలేటెడ్ టు సర్కిల్ ఆ చాప్టర్ గురించి మనం తెలుసుకుందాం. వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ ద చాప్టర్ రిగార్డింగ్ ఏరియాస్ రిలేటెడ్ టు సర్కిల్స్. Before going to answer this question, we have to know some technical terms in this chapter. First one is a circle is nothing but the locus of all points which are at the same distance, which are at the constant distance from a fixed point. A circle is nothing but the locus of all points, which are at constant distance from the fixed point, and that fixed point is called as the center of the circle, and the distance between the center to the point is called as radius of the circle. Okay, this is radius of the circle, or this is center of the circle, let it be O. And the next one is the line joining between any two points on the circle is called as chord. The line joining between any two points on the circle is called as chord. For example, this is AB chord. And the next one, the biggest chord of the circle is nothing but diameter. The biggest chord. This is the line joining between two points on the circle. Just join the 2 points only. Join between 2 points on the circle. This is A, this is B. AB line segment is joining between 2 points on the circle A and B. This is also called as chord. According to the definition of the chord, the line joining between 2 points on the circle is called as chord. The biggest chord of the circle is called as diameter, and it is passes through the center of the circle. Okay, sometimes they may be asked like this: what is the name of the chord which is passes through the center of the circle? What is the name of the chord which is passes through the center of the circle? Okay, diameter is always passes through the center. The chord which is passes through the center is called as diameter. Okay, the biggest chord of the circle is also called as diameter. And the next one is how many chords are possible to draw for a circle is infinity. How many chords? This is a chord, this is a chord, this is a chord, this is a chord, this is also chord. How many chords can be drawn for a given circle is infinity. Okay, and next one is this is the center of the circle. O is the center of the circle, and these are the two radiuses. And this is called as arc, and this total figure from this circle is called as sector. Therefore, sector is nothing but it has a center as well as two radiuses of same length and one arc. The combination of arc and two radiuses is called as the sector of the circle. In any circle, at the center we have 360 degrees. In any circle, center we have 360 degrees, and angle in the semicircle is 90 degrees. Angle in the semicircle is 90 degrees. Angle in the semicircle. In any semicircle, you have to take an angle. It is 90 degrees. But the point is, angle in the semicircle at the center is 180 degrees. Angle in the semicircle at the center is 180 degrees. But angle in the semicircle, there are a lot of difference between angle in the semicircle and angle in the semicircle at the center is 180 degrees. Angle in the semicircle is 90 degrees. And next point is the line which touches the circle is called as, which touches the circle at only one point is called as tangent of the circle. Is called as tangent of the circle. The line which touches the circle at only one point is called as tangent of the circle. And for a given circle, we can draw infinite number of tangents. For a given circle, we can draw infinite number of tangents. These all are the tangents which touches the circle at only one point is called as tangent of the circle. Okay. In circle chapter, we already know it. Whatever it is, I have to recall it. Okay. And this is tangent. And next one is the line joining. The line which intersects the any 2 points on the circle. The line which intersects. Intersects means it passes through the points and cross the points. For example, this is AB. This is called as secant. Secant line of the circle. What is the secant line? The line which intersects any 2 points on the circle. In the definition of chord, we already learned the line which joins any 2 points on the circle. But in the case of secant, the line which intersects any 2 points on the circle is called as secant line. For a given circle, we can draw infinite number of secant lines. For a given circle, we can draw infinite number of tangents. For a given circle, we can draw infinite number of chords. For any circle, we have infinite number of diameters also we can draw. Why infinite number of diameters I told? This is the center of the circle. The biggest chord of the circle is called as diameter, and it is passes through the center. And it is passes through the center. Now this can be written as, this can be drawn like this. 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 Whatever it is, these all are the biggest chord of these circles. Passes through the centers and also called as diameters. Okay, let me recall once again. The line which joins any 2 points on the circle is called as chord. The line which touches the circle at only one point is called as tangent. The line which intersects any 2 points on the circle is called as a secant of the circle. And next one, we can draw infinite number of chords for a given circle. We can draw infinite number of diameters for a circle. We can draw infinite number of tangents for a circle. We can draw infinite number of secants for a circle. Okay. And the angle in the semicircle is 90 degrees. Angle in the semicircle at the center is 180 degrees. Angle in the center at the angle of the circle at the center is 360 degrees. Okay. Let us come to the point. In this chapter, we are going to calculate areas of the circles, areas of the circles related to the circles. Areas related to circles. This is the circle having the center O. Having the center O. In this circle, the angle at the center is 360 degrees. 360 degrees. This is the sector of the circle making an angle of, for example, this is radius, this is also radius, making an angle of theta. Making an angle of theta. Making an angle theta. Why? Because these two rays starting at O having the common vertex. Okay. This is the angle of theta. We know that area of the circle is pi r square. Pi is nothing but 22/7. And it is also sometimes approximately equal to 3.14. We can calculate whatever it is. Pi is March 14. Next, area of the circle is pi r square. Area of the circle is pi r square. This total area contains 360 degrees. Okay, therefore, this total 360 degrees is equals to pi r square. 360 for 360 degree circle, we have the area. Pi r square is the formula. Okay, but we are having an angle theta here. We don't know the value of angle theta. Okay, how much angle, whatever it is. We don't know what is the area of this circle making an angle, for example, theta. For 360 degrees, we have pi r square. This is we have to calculate. What is the area for a sector making an angle of theta? What is the area of the sector making an angle of theta at the center? Okay, this is the area of the circle making an angle 360 degrees at the center. But here we have to calculate what is the area of the sector making an angle of theta at the center. Okay, the formula is nothing but theta by 360 into pi r square. Okay, this is direct proportion, right? This is direct proportion. For 360 degrees, we have pi r square is more. For theta, which means less than 360 here. This is less than 360. We have less area for the sector. Okay, that's why we have cross multiplied here. Question mark opposite to the question mark will comes to the denominator. Theta by 360 into pi r square is the area of the sector. Remember this thing. And next one is area of the sector is 360 by theta by 360 into pi r square. And the next one is area of the circle is pi r square. Area of the semicircle is pi r square by 2. Area of quadrant pi r square by 4. Quadrant means this is the circle of center O. That area of this total circle is pi r square only. Area of the total circle is pi r square. Area of this semicircle, half of the circle is pi r square by 2. Area of quadrant of a circle. Area of quadrant means one part. If you divide a circle into 4 parts, this is the quadrant, or this is the quadrant, or this is the quadrant. This is the quadrant means 1/4. Therefore, pi r square by 4 is the area of the quadrant. Okay, in any quadrant we have 90 degrees. Why? Area of the quadrant is like this. Area of the semicircle is pi r square by 2. We know the formula. Theta by 360 into pi r square. In a semicircle, for this is the semicircle area. For this, in a semicircle we have 180 degrees at the center. Theta by 360 into pi r square. 182. Therefore, pi r square by 2 is the area of semicircle by using that one. Area of the quadrant, in any quadrant of the circle, it will have 90 degrees. Therefore, 90 degrees is the theta. Theta by 360 into pi r square. 0, 0 cancel, 9 1s 9 4. Therefore, pi r square by 4 is the area of quadrant of the circle. Okay. Now, we are going to calculate the given question. What the given question is? Find the area of the radius. Find the area of the sector of radius 6 centimeters. If the angle of the sector is 60 degrees, angle of the sector is 360 degrees, 60 degrees. This is the circle of center O. This is the sector which makes an angle at the center 60 degrees. And the radius what the given is 6 centimeters. Okay. Now radius R of the circle is 6 centimeters. Angle of the sector at the center is 60 degrees. We have the formula to calculate what is the area of the sector making an angle of theta at the center is theta by 360 into pi r square. Theta by 360 into pi r square. Therefore, we have on the place of theta we are going to substitute 60 degrees. 360 into pi stands for 22 by 7 into r square stands for r is the radius, nothing but 6 into 6. Okay, 0 0 cancel, 6 1s 6 6 are 36. Again 6 6 cancel. Okay, now we are having 22 by 7 into 6. This can be written as 22 by 7 can be written as 3.14 into 6. Or multiply these two, 6 4s are 24, 2 carry, 6 1s are 6 plus 2, 8 point. 6 3s are 18. We have point after two places. We have to point after two places. Okay. This 18.84 centimeter square is the area of the given circle of radius 6 centimeters, as well as making an angle of 60 degrees at the center. And the next question we have, find the area of the quadrant of a circle whose circumference is 22 centimeters. They are given quadrant of a circle. Quadrant of a circle. Now they are given circumference of the circle is 22 centimeters. Circumference means perimeter of the circle. I forgot the point to tell. This is the area of the circle. This is the center of the circle with point O. The circumference of the total circle is 2 pi r. Circumference of the total circle is 2 pi r, and this is two parts of the circle, semicircle, as well as this is one also semicircle, and these are the four quadrants of the circle. We have to calculate the area of each quadrant. Okay, area of any one quadrant, making an angle. Quadrant means 90 degrees in the circle. Okay. Now they given what they given, circumference of the circle. Circumference of the circle is 22 centimeters they given. What is the circumference? What is the perimeter of the circle? Circumference means 2 pi r equals to 22 centimeters they given. And next one, 2 1s, 2 11s are 22. Pi stands for here 22 by 7. We have to calculate radius. We have on opposite we have 11. This can be written as 11 1s are 11, 11 2s are 22. We have to calculate this one. R equals to 7 by 2 centimeters. When it comes to the LHS, it will get reverse. 7 by 2 centimeters. Okay. With radius 7 by 2 centimeters. Therefore, radius is 7 by 2 centimeters. 7 by 2 centimeters. We have to calculate the area of this quadrant. Making an angle means 90 degrees here. This is also nothing but a sector. Okay. Therefore, area of the quadrant is theta by area of any sector is theta by 360 into pi r square. Area of any sector in the circle, area of. Okay. Here, quadrant means 90 degrees at the center. Therefore, in the place of theta, we are going to write 90 here. 360 by 360 into pi r square stands for, pi means 22 by 7 into r square stands for 7 by 2 into 7 by 2. Whatever it is. Okay. 94s are 360. Understand? Next, 7 1s are 7. And next we have on cancellation we get a 2 1s are 2. 2 2s are 4. 2 11s. Therefore we have 7 7 7 1s are 7 11s are 77 divided by 2 2s are 4. 4 2s are 8 centimeters square. This is the area of the quadrant with a circumference 22 centimeters. Okay. Next question. The length of the minute hand of a clock is 14 centimeters. Find the area swept by the minute hand in 5 minutes. Okay. For this question, we have to analyze the clock here. This is the clock which is in circle shape, or it is if your clock is in rectangle shape, the minute hand and hour hand and second hand will rotate in a circle shape only. Okay. Now we have 12 here, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. These are the 12 hours. Okay. For this 12, we have minute hand is almost equals to radius of the clock. Why we take it as minute hand will completely touch the points, completely touch the seconds point. Okay, we have to, the minute hand completely touch the seconds point. When seconds, when the minute hand is rotate it in this direction, it will touch almost equals to radius of the clock. Is this 12 hours? This is 12 hours clock. Whatever it is. Find the length of the minute hand of a clock of 14 centimeters. Minute hand. The length of the minute hand is 14 centimeters. They given. 14 centimeters they given. What is the area swept by a minute hand in 5 minutes? 5 minutes. Before going to the question, before answer this question, we have some internal calculations here. Whatever the topic they given on the basis of clock. Okay, for example, the minute hand is at this place. For example, the minute hand is at this place. After 5 minutes, it will become for this place. It will come to that too. Okay, this is the 5 minutes. We have to calculate the angle at the center. We have to calculate radius. Already the given radius 14 centimeters length of the minute hand. We have to calculate the angle. How to calculate the angle between the two lines is given by for a circle, for a clock, minute hand is for 60 minutes it will make 360 degrees. For 60 minutes 60 నిమిషాలకి 360 డిగ్రీలు తిరుగుతుంది మినిట్ హ్యాండ్. ఫర్ 60 మినిట్స్ 60 నిమిషాలకి 360 నిమిషాలు అంటే 1 అవర్. 1 అవర్ పూర్తిగా అయిపోయేసరికి 1 అవర్ ఇట్ విల్ కంప్లీట్స్ 1 అవర్ it will become 60 minutes. For 60 minutes it will complete 360 degrees rotation. Okay, 360 degrees at the rotation. For 1 minute it will makes 360 by 60. For 1 minute it will 366. Okay na, 6 ones 66. Therefore 60 degrees for each minute. This is for minute hand only. For minute hand it makes 60 degrees, 6 degrees for a minute hand. ఒక నిమిషానికి నిమిషాల ముందు చేసేటువంటి కోణం 6 డిగ్రీలు. For 1 minute the minute hand makes 6 degrees of angle. Okay, the given, what they given, the minute hand has the length of 14 centimeters. Radius of the clock is 14 centimeters and the angle theta is not given. For 5 minutes, for 1 minute we have 6 degrees. For 5 minutes we have 5 into 6 is nothing but 30 degrees. Therefore the angle at the center the minute hand makes is 30 degrees. 30 degrees. What is the formula of the sector? Therefore theta by 360 into pi r square. What is theta here? 30 degrees by 360 into pi stands for 22 by 7. Radius stands for 14 into 14. Okay, on cancelling this one, 0 cancel, 3 ones 3 12s. Okay, 7 ones 7 sevens are 7 2s are 14. 2 ones 2 6s are 12. Again 2 3s are 6. 2 7s are 14. We have on the numerator 22 into 7. By the denominator we have 3. 22 and 7 stands for 154 by 3 centimeters square. This is the area swept by a minute hand of length 14 centimeters. Okay, this is in the case of minute hand. For example, what if they given hours hand? What if they given hours hand? In the place of 5 minutes they will give 10 minutes. In the place of for 10 minutes we have, for each minute it makes 6 degrees. For 10 minutes it makes 60 degrees. In the place it will give, they give 15 minutes. We have 15 into 6, 90 degrees. Okay, that means a quadrant. This is in the case of minute hand. What if they given hours hand? Hours hand means for 12 hours the hours hand makes 360 degrees at the center. For 12 hours it makes 360 degrees at the center. For 1 hour it makes 1230s, 30 degrees. For each hour, hours hand for 1 hour, hours hand makes 30 degrees at the center. Okay. This is the regarding minutes hand or the third question. What is the area swept by a minute hand in 5 minutes? And next question, in a circle of radius 10 centimeters, a chord subtends right angle at the center. Find the area of corresponding minor segment as well as major segment. What the given data is, this is a circle, radius 10 centimeters, whatever it is. Next one, a chord subtends a right angle at the center. A chord subtends right angle at the center. For example, this is the chord AB. What is the chord? The line joining between any 2 points on the circle. Okay. This is the chord which subtends angle at 90 degrees at the center. This is the center of the circle O. A. This is B. Yeah, this chord makes 90 degrees at the center. This chord makes 90 degrees at the center from OA, OB. This angle AOB is 90 degrees at the center. Okay. This is nothing but radius. What the given radius? 10 centimeters as well as 10 centimeters. Now we have to calculate what is the area of a minor segment as well as major segment. This is nothing but a minor segment. Minor. Below the area below the AB chord is minor segment, and this total one is major segment except the triangle, including the triangle. Okay. For this first one we have to calculate what is the area of minor segment. For minor segment we have to calculate, this is OA, for example this is Y, OA, YB. This is the total sector. Okay. First we have to calculate area of this OAYB. Area of this sector. OAYB is initially a sector. In this sector we have a right angle triangle here. This is 90 degrees. This is nothing but a right angle triangle, right? Right angle triangle. This is 90 degrees. This is O, A, 10. Okay. In this sector we have a right angle triangle. We have like this. This is nothing but initially a sector. This is nothing but a sector initially. This is a sector. Okay. In the sector we have right angle triangle. We have to calculate the area of this one. First calculate the area of OAYB sector. First calculate area of OAYB sector. OAYB sector. In this sector we have 90 degrees. The area of sector is theta by 360 into pi r square. Theta by 360 into pi r square. Which means angle they given. What is the angle? 90 degrees. Therefore 90 by 360 into pi stands for 3.14, or sometimes we will take 22 by 7. 3.14 they suggest. R square stands for radius into radius. 10 into 2. Therefore 91, so 19 4s are 36. Sorry. 0 0 cancel. 94 is 360. On cancelling we get a next one. 2 5s are 10. Sorry. 2 2s are 4. 2 5s are 10. Again 2 5s are 10. Therefore on the denominator we have 3.14 into 5 into 5, which means 3.14 into 5 into 5, 25. What is the value of 3.14 into 25? 5 4s are 20, 5 1s are 5 plus 1 7, 5 3s are 15. We have 2 5, 2 4s are 8, 2 1s are 2, 2 3s are 6. 0, 15, 8, 7. 7, 8, 3, 0 is the area of this sector. We have point after two places. Therefore, 78.3 centimeter square is area of this sector only. But we are going to calculate area of the segment, minor segment. Area of the minor segment AYB, not OAYB. OAYB is the sector. Here AYB is the minor segment. AYB is the minor segment. We have to calculate the minor segment. This is the total area of the sector. This is AYB. We have when we get therefore area of triangle OAB. In the sector we have AOB right angle triangle. AOB is the right angle triangle. First we have to calculate the area of this right angle triangle, which means half into base into height. Half into base into height. Area of triangle half into base stands for 10, height also 10. Therefore 10 into 10, which is 2 5 are 10. We have 50. 50 centimeter square is the area of the triangle in the sector. Now we are going to calculate area of the minor segment. Area of the minor segment we have to calculate. For this area of the minor segment, in this minor segment we have rectangle triangle as well as AYB minor segment. In this total sector, if we subtract the area of the triangle from this total sector area, we will get minor segment. చూడండి, ఈ టోటల్ సెక్టర్ లో నుంచి ఈ రైట్ యాంగిల్ ట్రయాంగిల్ ని తీసేస్తే మనకి మైనర్ సెగ్మెంట్ వస్తుంది. ఓకే, టోటల్ సెక్టర్ లో నుంచి OAYB ఈ టోటల్ సెక్టర్ లో నుంచి ఈ రైట్ యాంగిల్ ట్రయాంగిల్ ఏరియాని తీసేస్తే మైనర్ సెగ్మెంట్ వస్తుంది. ఇఫ్ we subtract area of the right angle triangle in from the sector OAYB, we will get area of this minor segment. Therefore area of minor segment is area of minor segment is area of OAYB. Area of OAYB total sector minus area of the triangle. Area of triangle OAB. Area of triangle OAB. What is OAYB area? 78.3 minus. What is the area of the triangle? 50. We will get, what is the difference? 28.3 centimeter square. This is the area of minor segment. Area of minor segment. Area of minor segment. Next, now we have to calculate second one, area of major segment. We have to calculate area of major segment means this is a chord AB, this is area of minor segment, this total is area of major segment, including the triangle also. This total comes under major segment. This total comes under major segment. Total comes under major segment. The part below to the AB is minor segment. This is major segment. If we subtract area of minor segment from area of this total circle, we will get major segment area. Okay na, ఈ సర్కిల్ ఏరియాలో నుంచి మైనర్ సెగ్మెంట్ కనుక తీసేస్తే మేజర్ సెగ్మెంట్ ఏరియా మనకు వస్తుంది. అది ఎలా ఉంటుంది? ఫస్ట్ ఏరియా ఆఫ్ ద సర్కిల్ క్యాలిక్యులేట్ చేద్దాం. ఏరియా ఆఫ్ ద సర్కిల్ క్యాలిక్యులేట్ చేస్తే ఏరియా ఆఫ్ మేజర్ సెగ్మెంట్. ఏరియా ఆఫ్ మేజర్ సెగ్మెంట్ కోసం మనం ఏం అనుకుంటాం? ఏరియా ఆఫ్ circle. First we have to calculate area of the circle. What is the area of the circle? Pi r square. Pi r square stands for 22 3.14 into R stands for 10 into 10 radius. Therefore, we have 3.14 into 10 into 10 100. This can be written as 2 zeros, 2 points cancel. Therefore, that 314 centimeter square is the area of the circle. If we subtract the area of minor segment from this total sector, we will get area of major. Okay. Area of circle minus area of minor segment. Area of circle, what is the area of the circle? 314 minus area of minor segment is 28.3. Okay, if we subtract area of minor segment, area of minor segment from area of circle, we will get area of major segment. Therefore, 314 minus 28.3 is 283. Okay, 283 centimeter square approximately. 283, 3.14 minus 25. 285.3 centimeters. This is the total area of major segment, area of minor segment. Like this we can calculate.